What's up, y'all? I got a request to talk about a little paper here. Um, Transformation of a star into a planet in a millisecond pulsar binary. It says here PSR J1719 1438, a 5.7 millisecond pulsar was detected in a recent survey with a Parkes 64-meter radio telescope. We show that it is in a binary system with an orbital period of 2.2 hours. Its companion's mass is near that of Jupiter, but its minimum density of 23 grams per cubic centimeter suggests that it may be an ultra-low mass carbon white dwarf. This system may have once been an ultra-compact, low-mass X-ray binary where the companion narrowly avoided complete destruction. So all they're saying is there's a really powerful spinning pulsar, and then there's an object that orbits it. It's this massive Jupiter, and that's also very dense as well. And from this, their transformation of a star aspect is the realization that, hey, the object orbiting it could have been a lot more massive. And that pulsar in the center ripped away its outer layers to expose the core of it, which is, all theoretical, but that's basically what it boils down to. That's basically it. I don't have any problem with it. But then I started looking at, oh, well, what is this object really about? What was there? Is like a large bunch of propaganda concerning it. And yeah, there happened to be a lot of propaganda concerning it, because at the very end of the paper it says that the object is probably a large crystallized diamond. It's the first diamond world. Now, I don't have any problem with there being diamond worlds. I really don't. I think the idea is pretty freaking cool, to be honest. The fucking giant diamond. Sorry for cussing. But, it's kind of weird because you don't really need really fantastic things to pique people's interests if you know what you're talking about. But sometimes maybe you do need diamond worlds to interest people, and I think that's the main gist of it, is that they're trying to interest people in astronomy. Say, oh, well, we found a whole diamond world, isn't that interesting? But it doesn't really, pique my interest too much, I guess. I read this stuff all the time. It's like, oh, diamond world, okay, whatever. Who cares? But that being said, whether or not it is a diamond planet, and whether or not it was a star, and whether or not it transformed from a larger state, that's all up in the air. It's not really my issue with this. My issue is a lot of the times people take these documents and they're not skeptical of the claims that are being made. And that being said, I think it's healthy to be skeptical of all claims made by anybody, even myself. I'm skeptical of myself, even. At times, so skeptical that I don't even write anything down, just like, to hell with it. But that being said, if you can be skeptical about this stuff, and you look at it and think, maybe they're just telling people this for some other reason other than that's what's actually there. And even if this thing is real, if it's a diamond planet, then it would be what I considered an outlier. Meaning, sure, you have the mean of all the objects that evolve from a star-like state down to something like a planet, like the Earth, or Jupiter, or Neptune. You need to be able to say, well, okay, we have all these observations of millions and millions of objects, and they all go down this simple path. Millions of objects. But then we have this one object that just becomes a giant diamond. That doesn't mean that, say, oh, well, all these objects have to go through a diamond stage of stellar evolution before they become something like Earth. And that's just not reasonable, because a diamond planet would be a major outlier, such as red giants are also outliers if they're actually full-blown stars and they're not just bright clouds. I know a lot of people have problems with that, but I think red giants are outliers, diamond planets are outliers, and now they have a concept called quark stars. And I think even if those were to exist, I think those would be major outliers as well, because they don't follow the mean. And the mean would be like a, let's see, let me fold this. The mean would be like you have a graph where you have a bell chart here. The mean would be the rocky ocean worlds and the worlds that, you know, are like Earth, that have a lot of water, and even, you know, objects that are a little bit smaller than Neptune. That's the vast majority of evolving stars in our galaxy. And then towards the larger aspect, you have the gas giants, and those would be over here. Then you have the really bright stars, and it's a very small portion of those. And this isn't exacting, but I would have those as being at least 2 standard deviations from the mean. And then you'd have what I would call strange stuff. But yeah, that would be even further. And then if you really want to go into diamond worlds and, you know, red giants and stuff like that, you would move way over here, and they would just be like rare cases of those objects being there. And on the left side of the diagram, you would have dead worlds, asteroids, 2 standard deviation, and then you have, you know, the small asteroids and pebbles, and then you have protoplanetary disks, circumstellar disks, and this stuff way to the right. That's the really rare stuff. To find at least. Now, this is something I need to work on, but I think the reason why I needed to make this talk is that we can't be too careful of accepting things that are unusual as being the rule of thumb, and forcing those things that are unusual to be, you know, to have to force them to fit into the average. And a good example for this would be like, okay, business success in life. I would consider Elon Musk and Mark Zuckerberg to be basically the epitome of, I did everything right, now I'm a super, you know, extreme billionaire, and, you know, I can basically do whatever I want, you know, with rules attached, obviously. You know, you can't do things that are illegal. I mean, I'm sure they do illegal stuff, but, you know, I'm not going to go into that. But to say that is the average, that would be an injustice to all the kids that go to college and get college degrees. Especially in the case of, you know, Mark Zuckerberg and Bill Gates, for instance. They both dropped out of college, I believe. And then, you know, if you're not a billionaire before you're 30, then you're a failure. And that wouldn't be right. And I think that's similar to taking things like diamond planets and red giants and trying to force them into stellar evolution models just so we can have a complete picture of star evolution. I don't think that's where we're headed. I think we needed to take objects that we observe a lot of, which is now becoming the evolving stars, the evolved stars, which, you know, astronomers still call exoplanets, and place them on a larger connected dots kind of scheme. And as more observations are made of those exoplanets, we'll find out that that is the actual average, and that red giants and diamond planets are the outliers, and we don't have to force them to be representative of anything in star evolution. They could just be weird things that happen sometimes, you know, but we don't have to force them to be representative of what actually happens to the majority of the stars just because they're there and just because they're exotic. You don't need to make these things as, you know, the belonging to the mean, when clearly they're not average objects. They're really weird. As well, let's see. Oh yeah, I had this is off the other topic, off that topic, but I remember I drew this diagram. Baz, I don't know if I showed you this. This is something I drew in like 2013, I think, but I thought it was a really cool little pattern there. I just found it. I was like, whoa, where'd that come from? But it has white dwarf, you know, expanding outwards, and going all the way to, you know, larger stages and then it cooling and collapsing on itself. But I just thought that was weird. Anyways, I think I made this video long enough. Yeah, and you know, keep that in mind. Don't let these people and news organizations and major scientists and major universities try to, like, you know, convince you that, you know, this is true or that is true without first looking at them with a skeptical eye. Don't trust what they say just because they come from a major university. And this day and age, with, you know, a lot of the news media and them telling us, you know, this is true or that's true, and you have to go to secondary sources and be like, no, that's not exactly right. I think it's healthy to do that with astronomy related matters as well, and science related matters, because, you know, when you have all that money involved, when you have all those people that have a lot to lose if they're wrong, of course you're gonna have to sift through a lot of the half truths, if you will, and get to the bottom of the issues. All right, you guys. Today is December 29th, 2018. Hopefully you guys have a good new year, and I will be working a lot more in 2019 to get this theory worked out as best as I can. All right, y'all. Later.